Hello guys, welcome again to the live session. Myself Shamil Bato and you're watching School Quiz. So again, we are going to talk about the chapter number 5 in our NCRT book, the periodic classification of element. In the last session, we will discuss about some important points regarding with this chapter. Now, today we are going to discuss about the periodic table and let we understand that how the periodic table is made and how many things that we can understand in this specific table to enhance our knowledge, right? So let's start with our starting. Let's say for centuries, scientists have tried to figure out what makes the world around us ancient. Like, so ancient Greek believed that there were the four basic elements, that everything was made up of earth, like, let me draw something. It's like this is the earth, and the earth is made up of four major things that ancient Greeks believed that it's like earth or the soil, like air, water, and fire, right? So the ancient believes that they are the four basic materials that we are all of made up of, right? But what they didn't know was the universe and its composition was right in front of their eyes. Okay. The discovery of these components revolutionized our understanding about the world today. Like, we are living in this world and we have that greater knowledge according to the ancient people. And right now in the modern life, we got some more important things and important points to live in this live in this classic world, right? So as of now, today we have discovered 118 elements which fit together in a table. Let me show you. There it is, right? Oh, okay. Single most important and advanced learning aid in the world of chemistry, right? This is the most advanced aid for learning in the chemistry. If you understand these elements properly or the periodic table completely, you will definitely gain the knowledge of chemistry about 30 to 40%. Okay, like the physical and the chemical properties. It permit, or we can say that it permit us to predict the properties and chemical reaction of these elements, right? These elements that are present here, we can easily opt out the chemical reaction and properties by a help of this specific periodic table. Okay. The periodic table is divided into met on the left, as you can see, the left portion here. They are the metals. And on the right hand side, we have got non-metals. And in the center, as you can see, this zigzag line that divides the metal and non-metal in different colors. Like, so these are the metalloids. Okay. By looking at the position of an element, and these position representing the modern periodic table. In the modern periodic table, elements are arranged in 7 horizontal rows. As you can see here, the rows, these 7 rows, 1, 2, 3, 4, 5, 6, and 7, these horizontal rows are known as periods. And these vertical 18 rows are known as groups. Let me draw this completely, like from here to here. Okay. So these are the 18 groups and these are the 7 periods present in this periodic table. Okay. Elements with similar properties belong to the same vertical column. For example, all the element of the first group, like as you can see, This is the first group, and all the 7 elements, as we count 1, 2, 3, 4, 5, 6, and 7, all the 7 elements possess the same properties or the similar properties, like, and the vertical column. For example, as hydrogen react with oxygen, let me draw this. H2 plus O2. When hydrogen reacts with water, it forms what? We got 2H2O here, right? That's 2H2O. And all of these elements, when react with oxygen, they form the metallic oxides. These are the metal. Remember, these are the metals, and when they react with the oxygen, they form the metal oxides. Okay. So all of them in the first group, when they react with oxygen, they form the metal oxides. Okay. Apart from the 7 rows, there are 2 additional rows of 14 element, like as you can see here, like this one and this one as well. So these are known as the lanthanides and actinide groups. Okay, they are having the 14 element out there, and similar in this actinide also, they are also having the 14 element down there. But would it surprise you, or we can say that the periodic table is the first table of element, and you will not probably or never getting these knowledge according these element in the ancient times, right? So many of the scientists come and go, but the main scientist who arrange these elements according to their chemical and physical properties or their chemical reactions is Dmitry Mendeleev, the scientist who designed this complete table. But not in the first time. He also managed some problems according to these specific criterias. So let us draw our attention to this scientist, the Dobrinier. Okay. Johann Wolfgang Dobrinier, a German chemist, tried to arrange the element with similar properties into the group. According to Dobrinier law of trade, right? When 3 elements having similar properties are arranged in order of increasing atomic masses on the basis of atomic mass. Okay, they are arranged on the basis of atomic masses. Till now, at the time of Dobrinier, the atomic number was not completely discovered or not being given by any of the scientists. The theory was not given by any of the scientists. So Dobrinier arranged these 3 elements according to the increasing atomic masses, right? In its periodic table or in its table, to the atomic mass of the middle element is equal to, he also indicates that the middle element is equal to the arithmetic mean of the atomic mass of the 2 other elements. So as we can draw right here, if I draw a specific table of 3 elements, so we have got element 1, element 2, and element 3. They are arranged in the increasing atomic masses, right? In the increasing atomic masses, and they having the similar properties. And the middle one having the arithmetic mean of these 2 specific masses, right? Now let's look at an example again, like as we draw another table here according to this, and now we are going to add lithium, like Li, sodium, and potassium as well. Okay, so the atomic masses are lithium having the atomic mass of 7, sodium having approximately 23, and potassium having 39, right? Now, if we look at the mathematical relationship between the masses of these elements, we see the average of the atomic mass of lithium and potassium is approximately, or we can say that minimally 39. Okay. 2 of its atomic mass of sodium is that of 23. So if we compare the triad, um, wait a minute, wait a minute. There's something wrong. Nothing wrong. Okay, 39. Okay. Okay, sir. Now it's fine. No problem, sir. So if you compare the triad with the current position in the periodic table, all three elements belong to the same group, right? Belong to the same group. Like I said before, the three elements that form the triad exhibit similar properties. In this particular case, lithium, sodium, and potassium are metals. Okay, as we discussed in that the left hand portions are known for the metals in the periodic table. So these are the metals: lithium, sodium, and potassium. Secondly, all of them react with water to form alkaline and hydrogen gas. All of them react with the water to form the alkaline metals and alkaline substance and the water as well. Okay, sorry, hydrogen gas as well. And lastly, they are all having the valency of 1. As we can see, if if they belong, in the last session, I have discussed about the valency, and I have wrote this thing that first group contained the +1 valency. Okay, and in the second group we got the +2 valency. In the third group we got the +3, and in the fourth we got the plus and -4 valency. Just because the element in the fourth group having 4 electrons in the outermost orbital, and they can share up to 4 electrons with the other element as well, right? So in the fifth group we got -3 valency. In the sixth, we got -2. In the seventh, we got -1. And in the eighth group, we got the 0 valency, just because of the outermost orbital is completely filled with the electron. The electronic configuration is completed in those elements, and those elements are also known as the noble gas, and the configuration they achieve is known as the noble gas configuration, right? I hope you all of you understand this concept. So the lithium, sodium, and potassium having different atomic masses, and they are arranged in the different increasing atomic masses, and the arithmetic mean of these two specific elements having the uh, mean value for the third one, right? Again, like calcium, barium. Let me draw once more. Let me draw your attention to the periodic table again. Yeah, right up there. So here we can see calcium, magnesium, and beryllium, right? Example, they are another example of the trade. So as we wait, let me use a different color. We use these three elements as a triad according to the Dobrenier, right? And for another trade, we use these three elements as well. Okay, in the next triad. So these triad belongs that they having the increasing atomic masses. They're having the increasing atomic masses like that. So as we have discussed that they have the increasing atomic masses. So in this periodic table, when we go down the group, when we go down that specific group, so we have one thing is common here, that atomic mass will increase. Atomic mass will increase. So if we talk about the francium that is present in the 87th number, and if we talk about the hydrogen that is the first element of the periodic table, they having different atomic masses, and as we go down the group, the atomic masses will increase and increase again and again. Okay, right? I hope you all of you understand this concept. again. Um, and now let us go to the another scientist who helped to fill up these elements in the periodic table, and he is, where is he? I don't know. Okay. Newland law of octave, right? As you can see here, that is clearly written that attempts of Dobrinier encouraged other chemists to correlate the properties of element. It means that Dobrinier attempts encourages many other scientists to correlate the properties of the element, or these elements having different properties according to their sizes and according to the number of electrons that are present in between. So many scientists come and go, and the John Newland and English scientists arranged that known element in order of increasing atomic masses, as same as the Dobrinier do, right? As same as the Dobrinier done. So Newland law of octave states that when elements are arranged in the order of increasing atomic masses, the properties of every eighth element, according to the Dobrinier, the properties were similar in three elements. Okay, but according to Newland, the properties of elements of increasing atomic masses correlate with eight other elements: 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So according to them, they are arranged in the increasing order or in the increasing atomic mass, and the property of every eighth element, like every eighth element is similar to the first element of the another group. Okay. The first element, just like the eighth, the first element that is present here is just like the eighth one in the next. Okay. So as we can see, this first element possessing the property of these element in the next group. So as we can see, he uses a musical scale. He uses a musical scale that, as I said in the last session, that he used a musical scale resemble the first note. As you can see when I'm drawing, like sa, re, ga, ma, pa, dha, ni, and sa again. Okay, sa re ga ma pa dha ni sa. Okay, sa re ga ma pa dha ni and sa again. Okay, so they are 1, 2, 3, 4, 5, 6, and 7. So the eighth one is correlating with the first element, correlating the properties of the first element. Okay, he arranged the element into horizontal rows of 7 elements. If you start with lithium, the eighth element after lithium is sodium. So according to law of octave, as we can see, let me draw one more thing here. Let me do one more thing. Wait. See, not like that. Not. I'm just showing this specific concept to you. But if we draw this like vertically downward like this, so sa, re, ga, ma, pa, dha, ni, and the eighth one is resembled to this. So if we draw lithium here and the rest of the element here, the next eighth element that belong to the periodic table is sodium and would be put here as well. So the properties of lithium and sodium should be similar. Should be similar. Okay. So that's what Newland want to say, that the properties of every eighth element is similar to the first element, as you can see here, like the lithium and sodium possess the same property. Okay. And what is the next topic? Lithium, sodium, and wait a minute. Let me draw your attention again to the periodic table. Yeah. As you can see, according to, let me erase these so you can easily identify the specific topic. So I hope we have only two participants, like we and me and Marcel. Okay, so okay, draw that scene. When do when two scientists, as we wrote, Dobrinier and Newland, show their effort in making of these specific table, then Mendeleev comes into comes into the form, and Mendeleev called this table of element as the periodic system, right? Mendeleev given the name as a periodic system of these elements, and now we commonly know it as the periodic table. And as I'm talking about, Mendeleev did not stop there. He was also the one to introduce the word periodic with respect to arranged element, a term we see or we use till today, but everything just didn't fall in place. And all that easily. There were gaps in the horizontal row, but the scientist was unoptimized instead of seeing this as a problem. So let me draw your attention to the older periodic table here. So as you can see the empty blocks here, there are some kind of problem Mendeleev cannot solve it just because the atomic number was not discovered yet. Okay, atomic number was not discovered yet. So he facing some of the problems regarding with that specific periodic table. So as you can see, the empty blocks is just because of the element were not sufficient. Element were not sufficient those days, and he knew that in future we will get the more number of elements. The drawback of Newland, it's the only thing that he just understand that many of the elements were found and no more elements were found in the future. So they gave his theory, and he also stated that no more elements were found in the future. So this is the basic tables, and it will enhance the all of the knowledge according to the periodic table. But Mendeleev proves it wrong just because he left these specific blocks in the periodic table having the similar properties. Okay, so as we can see, the scientist was unoptimized. So Mendeleev thought it simply that mean the element which belonged in the gap has not yet been discovered. Okay, so as we can see, Newland stops the work just because of less elements, and but the Mendeleev believed that many of the element will be found in the future. So Mendeleev thought it simply means that the element which belong in the gap has not been yet discovered. And that's why they go, not only he was also able to work out the atomic masses of the missing element and predict their properties. For example, that he left the gap after the aluminium and named it as the undiscovered. Okay, so the place that is gallium is present right here is empty just because of aluminium was not aluminium was discovered, and the next place is emptied, or the gap is emptied just because this element was not discovered out there. Okay, so now in the modern periodic table, as we see, after the aluminium we got the gallium. Okay, or we can say that he not only named the element but also predict the chemical properties, or he stated that like alumina will having the atomic mass of 68 and will be a good conductor of electricity, and having the metallic property like malleability and ductility also. Okay, having the properties of malleability and ductility, it will be hard and shiny as well. And let's talk about the physical properties like the melting point and the element that will be very low. So the melting point and the boiling point, he also stated that the size, the melting and boiling point, chemical reactions of these specific elements. Okay, so Mendeleev also simplify these things according to them: the size, melting and boiling point, and the chemical reaction that is having in it. Okay, elements surrounding it like behaved like something, and guess what is the missing element was discovered, and it turned out that Mendeleev was right after few years. So like Mendeleev also predicted that more element will be found in the future. So after some time, he discovered that after few years, the prediction of the scientists that discover a new element and named it as gallium, that is placed after aluminium. Okay, so as you can see here, the aluminium is present at the 13th number and having that specific 29 number atomic mass, and the gallium just down towards it in this 13th group. So why does we place these gallium into the group of boron or aluminium? Just because they possess the similar physical and chemical properties. They belong to the same group just because of the similar physical and chemical properties and the increasing atomic mass. The first thing that we have to understand, that the increasing atomic mass will be given throughout the system according to the Dobrinian. Okay, and it is also officially known as the gallium. Oh, and atomic mass is nearly 70. It's a good conductor of electricity, and it also what we can say, it is solid at room temperature with an extremely low melting point. So as we can see, the aluminum having the low melting point and also the gallium having the low melting point. Similarly, he predict properties of all the elements that were missing in his periodic table. And after numerous effort, Mendeleev successfully found proper periodic table, as we can see here, and he published this periodic table in 1872. In 1872, and till now we are learning the periodic table to understand the basic concept of the chemistry. And as we can see, it is look very different from its earlier version, as I show you, just because uh, that earlier periodic table is just different according to this newer or the modern periodic table. And Mendeleev and what we can say, the 8 vertical column called the group and the general formula of oxides and hydrides of element in every group are written at the top of the group. just to indicate the element is that particular group having the similar chemical properties, and these groups these groups are furtherly divided into some of the specific orbital blocks, like this is S block element, this is P block elements, and these are the D block element, and they are the F block elements, as we talk about the lanthanides and actinides as well. Okay, and now you can see as I talk about that the group 8, each group is divided into subgroups like A, B, and 3 element, which lie in the left hand side called the subgroups. And they are, as we talk about, this is the first group, and that is the 18th group. So they having different properties. As I told you in the last session, that they having different properties according to the diagonal relationship from here to here. They're having a different properties, and from down and to the down the group, they're having the different properties. Okay, I hope you understand this specific concept. And these two rows indicating the transition sorry, and the transition element, the three sets with lie in the fourth and fifth, sixth position. Like, sorry, not this. These are the inner transition elements. Inner transition elements, and these are the from the third to 12. We called it as the transitional elements. Transitional element. Okay. Now, for the remaining topics that we have left in the last session, so that's the thing. Okay. I think this kind of thing make you more complexing, just because many of you just didn't know about the shell, the orbital, and number of electrons in specific atom. So let us understand the specific concept. Okay, you will definitely understand it very clearly. Just drew your attention here. As you can see, they indicate the K shell, the L shell. Okay, so what are they? They are the energy levels in which the electron should be found in the electron cloud. Okay, so as I draw the nucleus in front, in between. Okay, and let me draw the shells. These are the shells. Okay, these are the shells. So let us name them. This is K, this is L, this is M. So for the K shell, as we can see, that is the innermost orbital and nearly close to the nucleus. So in the K shell, as we give it the number of N is equals to 2. So if we write the formula 2n square just to identify the number of electrons in that particular orbital or the shell. Okay, to find out the particular number of electrons in particular shell. And also we wrote the formula of n square to identify the number of subshell or orbitals, right? So if we put n is equals to 2, n is equals to 2, though we get what? 2 multiplied by 2 to the square, right? So what we will get? 2 to the 4 into 2 is equals to 8, right? So as you can see in the L shell or in this shell, if we put the number 2, so we will get 8 electrons in the second group, or in the first, if we put n is equals to 1. So according to this formula, 2n square, so 2 multiplied by 1 square is equals to what? 2 electrons. So as we wrote the electronic configuration of any atom, let's say, let us take an example of lithium. So we wrote the electronic configuration like that. We put 2 electrons first, and then the remaining electron in the second shell. Okay, so in this case, lithium having the atomic number of 3, and if we put 2 electron here, so we have only one remaining electron in the outermost orbital, and we will put it like that. Okay, and if you want to know the exact position of that element, you should understand that the s block element having the s subshell and p block element having the p subshell in its last form. So if we write the electronic configuration again, so in the first shell, so let us do one thing. Let me give you a brief idea according for this. Let's say there is a class, and few rows are there. Okay, so we will give it a name. We will going to give it a name. Let's say first row will be 1s, second row will be 2s, and the third will get 3s, and the fourth will get 4s. And if we use the sections, then we will give it as P block, and after that there is D, and after that there is. So in higher class, you will understand that if we draw these groups like this, so each of the student having the specific roll number. Okay, so this student will get the 1s, this will get the 2s, and again in the next one that this will get the 2p, and this will get the 3p. Okay, wait a minute. Okay, like this. So like 2p, 3p, and 4p here as well. And for the next one, for the third student, we got the 3s. So here we got the 3s, and there is the 3p, and then in the third row we will got what, 3d, and in the fourth row we will got the 4d, and for the f element we will get what, we will get the 4f from here as well. Okay, so as we wrote the electronic configuration, we have to move with this specific functionalities. Okay, so if I wrote the electronic configuration of any element, let's say sodium is the element, so I have to write it like that. First of all, I have to put 2 electron in the 1s orbital, like 1s orbital having the 2 electron, and now the number 1 orbital is completed, just because if we put the n value 1, so we will get the number of orbital 1 here, and if we put 2 here, so 2 square is equals to 4. So in the next section we will get 2s and 2p here as well. So in the s subshell we will fill the 2 electron, and in the p we will fill the 6 electron as well. As you can understand the specific concept. Okay, so this is the very basic things according to the periodic table. Okay, so let us recall all the things that we have learned today. Like as we go down the group, what are the properties that should be remind? Okay, as we move down to the group, let me write the things so you can easily understand it. I'm drawing this down the group. So as we go down the group, the atomic size will increase, atomic number will increase, atomic mass will increase. Okay. In the same group, if we go down the group, we will get these three properties. Okay. And the similar group possesses the similar properties as we talked earlier about it. Okay. And now as we move vertically, we will get that the electronegativity will increase. Okay. And if we move down the group, the electropositivity or the electron affinity will increase, that these elements having bigger in size will lose electron easily, bro. And as we can see here, these elements like fluorine is the most electronegative element in the whole periodic table. So it is very difficult to remove an electron from its outermost shell just because of higher intermolecular attraction, or so higher internucleus attraction in between the electron and the nucleus of the fluorine. So as we move down to the group, we can see that iodine can also loses the electron whenever necessary, but not the fluorine. Fluorine is quite cheeky at that time. And have you ever heard about the term Teflon, right? Teflon, the non-stick coating. Let me tell you an interesting fact about the non-stick coating of the Teflon, that Teflon is made up of carbon and fluorine. So accidentally, when scientists forming different kind of element, he accidentally discovered that non-sticky coating known as the Teflon. And this Teflon do not stick with any other element. So how the Teflon is pasted on the non-stick utensils as we used in this in the daily life. So the process is simple. The process is very simple. Let us take an example. Let us assume that this is a utensil plate. So first of all, the grading, or we have to grind that specific surface, and then first of all the process is grinding, and after that we put a hard sticking glue, and in the last thing we just covered out the Teflon covering over it. So the Teflon will get attached to that specific utensil, and the covering will protect any of the element to stick out or to stick in, right? So Teflon is an accidental compound made up of carbon and fluorine. So as we talk about the Lewis dot structure, of carbon, we will get 4 electrons in the outermost orbital. So these fluorine will get attached and get the remaining electron that is necessary for their electronic configuration or the noble gas configuration. They will get that specific electron from that carbon. Okay. So the carbon fluorine bond is so much stronger that it is also known as the non-sticky compound, that will not stick with other element, or they do not allow them to stick with other element as well. Okay. I hope you understand this specific concept. So in the first group, we already learned about many more things, and also same for the second group. Now come to this come to this 13th group element, and we having the atomic number of 5 for the boron, and approximately the atomic mass of 10.3. This element possesses the valency of +3, and what about the carbon? Simple as like plus, minus, and 4. And for the nitrogen, we will get a -3. Why the nitrogen will get the -3 valency? Just because the nitrogen having less number of electron in the outermost orbital and having the deficiency of 3 electrons. So if I draw the orbital structure of nitrogen, so this is the nucleus, the first shell, the second shell. This is the first shell and second shell. And according to the rules, we have to put 2 electron in the innermost orbital. And as you can see, if we put 2 electrons, we have only what, 5 electrons left. So sorry, we have 5 electrons left. So let me write 2, 3, 4, and 5. So as you can see, there is the deficiency of 3 electrons. There is a deficiency of 3 electrons. So nitrogen wants 3 electrons from any other element. Okay, from any other element that can give this specific nitrogen their electrons. So as you heard about the compound known as ammonia, NH3. So the nitrogen bond with 3 hydrogen to complete its noble gas configuration, and as well as the sharing between the nitrogen and hydrogen completed the hydrogen valencies as well. So if we draw the Lewis dot structure for the nitrogen, we will get like this structure. Right. So as you can see, the nitrogen share its 3 electrons with the hydrogen, and in between the hydrogen also shares its single electron with the nitrogen, and this will completed the electronic configuration for both of these elements like nitrogen and hydrogen will complete the noble gas configuration by bonding with each other or by the sharing of electrons with each other. So hope you guys you will understand the concept of these elements. This will help you a lot to understand this specific chapter, and this chapter is only depend on the properties and the similarity between the elements and the similarities between the elements. So if you want to learn the 30 and 40% concept of the chemistry, so first of all you have to understand that specific periodic table and what the periodic table consists of. All the 118 elements having different properties from each other regarding to the column section. But if we talk about the groups having somehow somewhat the similar properties. I know the values will be differ in terms of sizes or the melting and boiling point or how they react, but they will react as same, or we can say that helium, neon, argon, krypton, and xenon, all of them are put into the 18th group known as the noble gases group, but only the xenon shows reactions. Okay, only xenon show the reaction. Why is it so? As I told you that as we move down the group, the atomic mass increases. So if the atomic masses increases, then the atomic size is also increases. And if the atomic size increase, the internuclear forces will become weak. And due to that weakened forces, the xenon will form the bond with fluorine, like XeF2, XeF3, right? So in this case, xenon transfer its 2 electron or share its 2 electron with fluorine, and in this case, 3 electron with the fluorine. So we have few exceptions also. We have few exception also regarding with that specific periodic table. And as we drew attention towards these metals, or we can say many of them having different properties, like radium having the light absorbing properties and kind of fluorescent in the dim lights, okay, just because of they absorb the energy and they shine when they are in the dim light. So this is the better things that we have to understand the basic concept regarding to the chemical and physical properties of these elements, and we clearly understand with the help of the periodic table. And few of the exception you have to learn about those things, and these exception will also lead you to the chemical reactivity of these elements throughout the chemistry. If it is physical chemistry, or if it is inorganic chemistry, or if it is organic chemistry, all of the things will help you to understand these three subtopics of this chemistry. Okay, so we have metals, we have non-metals, we have metalloids as well. They're having the different physical properties, they're having the different chemical properties, or the melting and boiling point. So as you learn in the physical chemistry that many of the things regarding to the melting and boiling point, the size, the bond length, etc. And in the organic way, you must understand that how the element will react in the inorganic way. And if we use in chemistry in our daily life, we use the organic chemistry concept. So if you learn that specific periodic table, you will definitely understand these three concepts of physical, inorganic, and organic as well. Okay. So I hope you will definitely learn that first element and 118th element, what they are common and what they are similar between them. Okay. So that's all for today's, guys. Thank you so much for watching, and I hope you will get the better marks in your exam. Prepare well, and I'm here just to help you again and again. Okay, so if you have any doubt, just comment below and give us a thumbs up and a like, and please subscribe to our channel. Thank you so much, guys. Thank you so much.